Hi, everyone. To start off with, I'm just going to say that this talk is going to be a little bit different from the others. Everyone else has been very machine learning-y, AI-y, and I'm coming from a slightly different kind of perspective. So I'm from University of Manchester, which is part of Elixir UK. There's a stand outside. You can go and see what we do, what services and tools we have. And next to it, you'll find the Biofair stand as well. So I think that's 2 beers for me later on. So what I'm going to talk about, I'm really focused in the FAIR space. So we do a lot of work on European projects, working on FAIR, verifying data, things like that. I know a little bit about knowledge representation, but when it comes to AI, not so much. But I've learned quite a lot in this conference, and I've got some ideas about where FAIR can go towards helping with AI and ML. So that's what I'm going to try and talk about, and hopefully you bear with me and maybe educate me later on. One thing I want to say early on as well is that I'm going to talk about bioschemas, which is obviously around the bio domain. But I want you to think more about the strategy and what we do, the community, and think about how it could be applied outside of just bio. Right, so what I'm going to talk about is the bioschemas way. So that's all around community, which I'm going to talk about, who we are, why we do the things we do. And essentially, in a nutshell, it's a markup for biological resources. So embedding things within web pages, web resources. So I'll talk about how we work, and I'll talk about 3 examples very quickly, not going into too much detail because it's only like a short talk, and the kind of things we want to do and how you get involved. On the right-hand side, you see a graphic where we were very careful not to infringe any kind of copyrights. In fact, maybe a bit too careful. But the focus there is the non-bio part and the FAIR and the fairly, because the acronym itself has started to be co-opted as a fairly AI ready or finally AI ready, whichever one you prefer. So first I'm going to talk about the community. So I said it's like a extension to web markup based on schema.org. I'll talk about schema.org in like a slide. But what I want to talk about on this slide is really like the community. So how we work. And what we do is we establish like a use case and what is it that you want to address on a web resource around a particular domain or like a protein or a gene or whatever. And we build together this little community, and we get people to like lead that effort, develop a group discussion forum. And of course, if you have a working group and you have leads, you need to build process, and you need to have documentation about how you go from having this community of people, the leads, and what their responsibilities are, and how you go from that to building a specification and releasing it and getting it approved and getting feedback. So we also have an established governance, which I think other communities could easily just take. It's open, everything, all of this is open. And the governance itself, we're happy to tweak. So one of the things we're doing at the moment is tweaking that to make it easier for groups to start off with bioschemas, or if you took this governance, other schemas. And we have a bit of a focus on developing tooling. So that's tooling for users to help generate, implement, and validate the markup you might use. And we also additional support. So that's really talking about documentation and help. So we have the website is really the first place you would go. The website is the focus, so making our materials more easily identified so people can find them and chaining them together where possible. And it's our 10th anniversary. So somebody can get me a piece of cake or something. So how we operate is we normally have these little, so it's largely a coalition of the willing. We don't really have much funding. We haven't really applied for much funding. So we find opportunities to have little hackathons, targeted, focused little groups. And there's an example there. I think in that one, I'm the only person that didn't know somebody was taking a picture because everyone else is turning around. So that was in Cologne. That was focused around training materials and learning paths and bioschemas and extensions and mappings to schema.org and that kind of thing. And the box there at the bottom just shows some examples of the sites that we have. There's 100 plus implementing bioschemas. So just a few words about schema.org. So schema.org was developed by Google and a bunch of search engines to enable things to be found on the web. So initially there was an e-commerce focus, but typically you would know it as indexing of films, books, things like that, creative works. And on the left-hand side, have I got a mouse? Have I got a mouse? No. So the Wizard of Oz, where that.
You can have a mouse, you can activate this.
Okay. So in this part, if you do a search, so it's basically a lightweight vocabulary covering all different types of things, and it doesn't go too deep. And actually, that's what Bioschemas does as well. It's really focused on findability, so it's not trying to be a whole ontology. But anyway, schema.org, lightweight vocabulary, talking about things, and the things are known to them as types. They call them types. And each of these things has characteristics or properties or traits that you would associate. So with a person, you'd have a name, number of legs or arms or whatever. So those are then properties. So here for film, which is the example I've got here, a film, I searched for Wizard of Oz and it knew I was looking for that. And on the left-hand side, you have, it's called rich snippets, which is the stuff that's indexed by these search engines and shown up. So you get typically like pictures at the top and then a list of clickable links. And on the right-hand side is an info box. And the info box is taken from the Google knowledge graph that they build. The good thing about schema.org is that there is a way to contribute. You can propose new types. And that's the kind of thing that Bioschemas does. And I've got some examples there. 2 of them are hyperlinked, so you can click that and you can go to schema.org and you can see that it's been contributed by the Bioschemas group. So what's different with us is that we're much more problem focused. Like I said, you assemble around like a use case, what it is you want to try and show. So we have targeted types and we choose fewer properties. So I think schema.org has something like 800 odd types. And the example on the right here is for dataset, and that has 127 properties. So if you had a dataset and you wanted to mark it up to make it findable on the web using schema.org, potentially you would have to go through, if you knew nothing else, you'd have to go through all those properties, see which ones are most applicable, and that's a bit of a burden. So Bioschemas are focused on identifying the key properties. So what we've ended up with is 6 key properties, which we call mandatory, and then 11 recommended. So that really narrows it down. It tells you what is the bare minimum that you need to have and what else could you provide. So we have fewer properties, which are profiles built over the top of these schema.org types. And we also provide a lot more guidance. So schema.org won't tell you, it will give you a description, but it won't tell you how many times that property can appear, what the values might be, whether it's mandatory or optional. So it makes it much more complicated. So, sorry. So the idea here is that we provide guidance for people that use this. So like I said, this is an example for bioschemas, but you could imagine that any domain could pick this up, like even astrology or something could build their own schema, astrology.schemas. So now just to give you like a few examples of how it's used, these are the benefits that you get from employing a strategy like this. So this is data federation, and this is the TESS portal. So TESS is the Elixir training portal. Elixir has 23 nodes distributed all around Europe. Each of those produces their own training materials, and they're scattered. But what we do with TESS is that if you register your resources in TESS, Bioschemas can scrape that and put them all together into a searchable interface. So this is the Bioschemas markup being identified and scraped in TESS, and then you can share that with other resources. So when you use something like Bioschemas or any other kind of schemas like that, you effectively have a contract of what, if you're trying to build services on top of that, you know exactly what to expect, and you know what you need to provide to make use of that kind of chain that you could then put together. So on top of that, you have a faceted search interface, which will work off all those pieces of information that you provide. And then you can use that to do, for example, calendar feeds or email alerts and things like that. So in this case, you can see at the top there, you use the bioschemas properties that have been listed in the profile, and then you just declare at the top that it complies with that particular profile. And in this case, we're using training resource, event, and course instance. So you can have multiple profiles within one page. This is another example. This is knowledge graphs. So this one, you may remember from yesterday's session, Christine Oregno. She talked about IDPs, so that's intrinsically disordered proteins, which are basically scattered around multiple protein database resources. And for those, it's very hard to have a structural prediction. So you could, within protein in the bioschemas profile, you can mark these up, and then they can be collected together and put into a knowledge graph, and then you can build a Sparkle query, in a Sparkle endpoint, and then you can have queryable knowledge graphs, essentially. And there's some examples here of some of the resources that are used to build that. The other thing that bioschemas allows is the evaluation of fairness, which is probably the most important one for us at the moment. So we have within our group built a tool called Fair Checker, which looks at evaluates the web page using the markup within the metadata, and harvests that, and there's essentially a mapping between the bioschemas property and which fair principle that is, and then you get on the right hand side here, you can see which fair principle it matches up against, and gives you a quick way to find out how you could improve the metadata that you have. So essentially, it's a proxy for those fair principles within the web page. There's another example here. So this is looking at 25,000 software entries in BioTools, and looking at the fairness that they have. So this is like a large scale fairness evaluation. And you can see on this part, yes, you can see on this part here that 100% of those matched for the mandatory properties. So they contained all the information needed at the bare minimum. And about 60%, so this is the range of the values. So this box here is like around 60%. About 60% of them had all of the mandatory, all of the recommended properties. So the other thing that we're doing at the moment is, so if you think about it, if you are not using a profile, we could look at other metadata that's embedded within a page, for example, DCAT, map that to what bioschema's property that would be and fair principles. So we could use those as a proxy for using bioschemas, and then also a suggestion service, which could say you have this, and this property. You're 75% of the way to being compliant with X profile from bioschemas or whatever schemas, and offer that as a service. So that's one of the things we're actually working on at the moment. Now this part I know less about. So I asked ChatGPT to help me with that and say, I know about FAIR. I don't really know about AI and ML. So please tell me, what should I do? I mean, but intuitively, you would think there has to be a relationship, because the FAIR principles start with or have in the text in multiple places. FAIR is necessary to enhance the ability of machines to process metadata, right? So that's the first part of the FAIR principles. And since FAIR is also all about metadata, you could address some of the things that I've heard about through metadata, because it's just tags and then you put the information in between, right? So reducing ambiguity. If you're using controlled vocabularies, then there's a shared understanding of what exactly it is you're talking about, so the machine should understand that. Building trust, that's around provenance. That you should be able to put provenance in there. I'm sure that there's parts that are more complicated. And specifying usage, like what's usable under what conditions. Some of that is licensed, some of it is not. So my question here is, what else is needed? So reading through this table, the F and the A, so as I said, bioschemas is focused really around the findability. The accessibility, not quite as much, and then wavering out on the I and R. I don't think FAIR really does that so much. But these entries, which I won't go through, for F and A, kind of makes sense to me, and I'd be interested to know if the I and R makes sense to you, and if you'd be willing to share your knowledge with me on those. So I did some reading on this, and I looked at, there's some standards. There's FAIR for machine learning, there's DOME, and there's Croissant RAI. So I had a look at those. And Gavin talked about DOME earlier on and gave a really nice summary. For me, I understood it even a bit more after that. And this is around data optimization model and evaluation. And what I understand is that they're general recommendations, but the thing that stood out to me was that they talked about topic-specific extensions and community governance to try and build these out, which sounds like bioschemas-y to me, right? Well, schema. So if you took out the topic, the community part sounds like what you would do from bioschemas, and the topic, if it wasn't bio, it could be something else, but extending towards a domain. So that was my take home from that. And essentially these appear as a kind of natural language text within a table that you provide on submission to your registry. And Croissant is like makes machine learning data sets findable on the web, and RAI, which is the responsible AI part, extends that. And that was built from a set of use cases. I think it was 5 use cases, so that the paper is there. And what I noted there was that, again, there's this co-creation, there's this community part, there's this vocabulary engineering, again, towards particular domains. So it says that you need to develop some domain-specific kind of extensions to that. And the other thing I noted was that Croissant, Croissant RAI is composed of these 3 parts, right? One is Croissant, one is the new parts, and one is schema.org properties. And I was just thinking, what if you just took bioschemas? Is that then enough to use for machine learning data sets from the bio domain? If there was something like astrology schemas, could you substitute that? And if not, what would you need in addition to that? And how would you do it? Would it be just a pointer from there to where you're going to host actually the details of the metadata? I think that sounds kind of like a way to go. So what we're doing now, so one thing we've noticed is that while working on bioschemas, a lot of the things we do, a lot of the profiles and types that we generate are not bio-specific. So we talk about data sets, computational workflows, courses, events, training. Those aren't bio-specific. But there's a burden associated with being bio. If you go to a conference or if you want to be involved in a project and you're saying, oh, we have bioschemas, and it's like, oh, yeah, but we're astrophysics. We have no need for you. So we wanted to remove that kind of obstacle from the usability of our work. So we created we now host a domain called schemas.science. And our current intention is to just put those domain agnostic profiles for other people to use. So you can come take those profiles, use them for your own purposes. But there is, yeah. So, so that's where we're now. So that's what we're working on in the future. So what my conclusion is that metadata bridges FAIR principles and going towards AI, promoting this community approach. There's some links there. Sorry, I'm running out of time, aren't I? There's some links there for how to get involved. So we've got like community calls, a 3rd Monday of each month. I've got a quick survey question at the end. We've got Slack. These slides are available there. So talking about that community part, I've got a survey here, which is basically saying we have this schemas.science site, and you can imagine that we haven't done anything with it yet, and we could do different things. So at the moment, we're planning to just host profiles there. But you could imagine that if other communities come and want to use a particular profile that we have, but it's not quite right for them, you'd want to have the ability to have a discussion to tweak that. So maybe add an extra additional optional property, for example. So that requires a bit more effort. And then you could go to the extreme and have like some, I mean, that's like not going to happen. But I was curious about the appetite within the audience for this, where you think that should be. So acknowledgements, I just want to thank Phil, Helena, who are over there, who helped with the slides. Layla, Alban, and Carol, who are also on the steering committee. Alistair Gray, I want to point out in particular, he's left us now. He's left Bioschemas. He's not dead. He's alive. He's left us. But yeah, he started this off, so we owe him a lot of thanks. The Bioschemas community, and that's it. Thank you.